everything's gonna work eventually. And it's kind of scaling on both sides. That's okay. In our case, that's okay. So as you can imagine, it's just gonna do the same thing all over again. So, and for one, it's just scaling in one direction. So there you go. You can actually just do a lot of crazy cool stuff with this. So make logos, animate, or make something with this. We also got the chop frame, but I haven't messed with that. Something you should do. So actually, if I pull up my text part and type in xhelp for chop frame, you can actually see that it also gets a string channel and a floating frame. So you can imagine what you can do with chops. You can have animated noise or something like that, and just read it into the sub level. So all handy and dandy. And by the way, this is not a one line, one-sided, whatever. You can get a sphere in our case, let's say, and make it a polygon mesh. Yeah, probably sphere is not the best example, but you get that there. Let's say you get a tube and make it a polygon mesh. And probably now you want to actually scale everything in the X, the Y, and the Z probably, and probably give a better direction. But anyway, you get the idea. I give you something to play with. So in that case, I'm gonna just go ahead and keep on using the lines. So for now, what we can actually go ahead and do is actually implement the whole thing in Python. So delete all of this. This ain't gonna work for us. What we needed was really Python. So here we go, Python. Okay, continuing from where we just left off. Okay, I don't know. Probably somebody might wanna kind of scale this up from the bottom of the box, kind of going up. So in our case, the easiest way out will actually be just make the pivot point go on the bottom. So his expression will be y minimum, and actually would scale up everything from the bottom going up, and same controls all over again. But now we come to the final part, which is the best part as usual. Save the best for last. So under file, new operator type, and right here we're gonna name this. You can name it anything. I just name it chan f. That'd be good. The operator name is gonna be, you can name something more descriptive than mine. I'll just name mine like this, and it's gonna be a Python type, of which it's not gonna be an object level. It's gonna be a geometry operator. So it's gonna be inside the geometry level. Then it's gonna be on the current heap file, and you might want to name it something else than the default name. So in that case, it's gonna be channel frame. You can put something more descriptive than mine. That doesn't really look too good. So it pops up our type properties page, and you got a whole lot of blah 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 that you can put up. In our case, with the tab we need is this code, and this is what you're gonna be looking at. So for one, what we're gonna go ahead and do is we got our thing set up. So we got tab, and on the digital assets now we got something just came up. This was not here when I actually began the whole thing, so it just got created right now, which is channel frame. And pretty much it has one input, but if you want, you can actually go ahead and reduce the number of inputs to 0, and that way, well, maximum number of inputs to 0, and that way it doesn't have anything on it. But in that case, just leave it as a default. So we're gonna be, I would say, use the box again, and the line, and the null. Everything else you can recreate from scratch, the copy sub too. So this one is gonna plug it into this one right here. So it's gonna be bringing in the data from right here. So pretty much you can see the flow. So we're gonna rebuild the thing again. So we're gonna drop in a transform for the box and a copy sub one more time. Right, so plug that in. So you can imagine how the flow is gonna be. It's the same thing as earlier. Matter of fact, it is the same thing as earlier. Only difference is now we got a Python sub in the middle of it. So let's go to the code section and let's see what we can work with. I'm gonna go and pull up my Python shell. So I'll shift P to just bring it in. You can, pop it up over here and just new operator type Python shell, but I need this to be floating for this particular time. So in our case, our geometry, in our case for right now, is the lines up, which if I actually pull it up to the side over here, is actually what we are reading in. So in our case, we got 50 points. We can actually go ahead and check on that. So right in the shell, I'm gonna go ahead and type in geo is equals to, I don't have to type in the whole thing. I can type in who.node is equals to blah blah blah, but I can actually just drag it straight down into the shell, and Houdini will actually write the whole thing for me. So I'm done with that pretty much. So then I can put in the geometry as the thing that I want to actually go ahead and read out. But if you're actually not used to that, you can actually just go ahead and type in geo. Now if you actually want a second job for that, is actually what geo.geometry. It's the same thing. Alright, so now under geo you can query the number of points. So let's see how many number of points we got. So we're gonna use a Houdini Python function, which is actually len, and we can type in geo.po. Then you can see everything you can do under the PO is right there, so points, and this is actually more of a function which calls its own self and brings back the value out of that. So you close the function and you close the len function also, so that way it gives you the number of points. In our case it's 50, and if you double check, 50, so we get, so for one, we're gonna create a variable over here called num points, which is just short for number of points, is equals to len of geo dot points, right? And don't forget to close the thing as we did. So now this one will leave us a value of 50 as it is. Now another thing we're going to be needing over here inside the inside our Python code over here is our attribute value over here, which is not attribute but the sample that we're going to be bringing in. So we're actually going to go ahead and name it sample is equals to, as well, again we're just going to drag it straight down in. I mean, we're gonna bother copying and trying to put all these names and blah blah blah. Very easy to make mistakes with that typo. So we got that. So kind of flowing good. So for now, if you actually look at this node right here, it has no point attributes, no point attributes, and no point attributes, none at all. So we're gonna go ahead and create that because we need to actually go ahead and read the point numbers. So we're gonna say add sample point, so to speak. It's just, you can name it anything. You can name it one x, you can know the letter, no numbers, so x, y, z, whatever you want to name it, you can just name it as that. So add sample is equals to geo. What we want to do to geo now, which is the geometry that we're looking at. So under the geometry, for the whole geometry, what you want to do is actually add an attribute, which is actually add an attribute value. And the attribute value, you actually need to specify the attribute value which you're gonna give to the add attribute, right? So the attribute value in our case is attribute type of what kind. Houdini needs to know what kind, so is it a vertex, a global, or prim, or point. So you can actually go ahead to the shell over here and type in who.attrib of type, right? Then if you put in a dot, you can actually see what you can actually put up. So you have vertex, this one, prim, point, MRO, or global. MRO, I can't remember what that is, but yeah, something like that. So in our case, we're gonna be putting a point attribute, so it's gonna be a point, comma, and the name for the point is for the attribute we're gonna be adding is called sample. All right, and the default value is gonna be a 0.0. Now it's gonna have to be a floating point because that way you can read all the values exactly. If you put a 0, it might work, but just do a floating point to be on the safe side. So we got that done. Now one thing we did earlier was actually use a HScript expression called fit, which actually doesn't come automatically in Houdini, but it's actually there, and it's in a function called hmap, well, not a function but a class called hmath. So under, I can do a hmath over here is equals to who dot hmath, right? Now if I actually look for whatever is inside the hmath variable which I just made up right now, so hmath, if I put in the stuff correctly, I can see the fit is actually in it. So what you're gonna go ahead and do for our little code over here is actually drop in hmath that's the hmath is equals to who dot hmath, right? So now we pretty much got everything set up, but what did we do before this? Let's see. Under the copy sub, we also had the point number, total number of points. So in our case, we can actually just go ahead, is that we already got that set up. So pretty much we pretty much set up everything. So we're gonna go ahead and iterate through every single point on the line sub. So we got 50 points, so we're gonna iterate 50 times